Hello everybody, my name is Roshni Desai, and this is my backward design teaching unit. For this unit, this is for my regular chemistry students. This unit is going to focus on ionic bond modeling. The goal of this unit is the students are going to learn how metals and nonmetals basically interact with each other in order to form ionic bonds. The different materials that are put together in this unit are solely going to focus on ionic bonding and different ways that you can model ionic bonds and how metals and nonmetals can interact with each other using their electrons. So I started focusing on the backward design model when creating this unit, and the backward design model kind of looks like this. You're first starting out with your desired results, and that is going to be my goal. So we're going to focus on ionic bonding. The next step is to determine the acceptable evidence, which you're going to use to incorporate and kind of work backwards from your goal in order to plan your different experiences and your lessons. And that goes to the third component, which is like the third stage of the backward design model, which you're planning your experiences and instructions and basically individual lessons based on your goal and whatever assessments or that you're trying to achieve during this unit. For my particular unit, my desired results is the goal for this entire unit was to model ionic bonding between a metal and a nonmetal using electrons and how they transfer. So I started with that when I was creating this different units because that's what I want the students to accomplish throughout the entire unit. So that's my end goal. That's kind of what I want to test. Then I started choosing different acceptable evidence of how I'm going to model this ionic bonding between metals and nonmetals. So the two things that I decided to accept as acceptable evidence is the first thing is electron configuration. We used that in our previous unit, and I thought that would be a good way of showing how ionic bonds can actually transfer their electrons through their electron configuration. And then there's just an image of electron configuration right over here. The next piece of acceptable evidence that I chose was our electron dot diagrams. They also talk about the valence electrons outside of different atoms, and they can use your valence electrons and transfer them between a metal and nonmetal in order to show that electron is being transferred. So those are my two pieces of evidence that I wanted to focus on. Once I came up with some acceptable evidence, I started compiling different lessons and learning events that I wanted to use to go back and just assess my goal. So I came up with two things. I came up with some content videos that I created. I came up with some on-course assessments, online assessments on using Google Forms. I came up with a playlist of activities that supplements the learning. And then I came up with this project which talks about both acceptable pieces of evidence. And then within those lessons, there's going to be a whole bunch of formative assessments that we can use in order to assess their learning. My different learning events are broken down into two individual lessons inside of this unit. So I said I did incorporate content videos, online assessments, different playlist activities, a stop motion project, and some assessments. So this unit, when I broke it down into two different lessons, this is actually going to be a flipped classroom unit where the students at home are watching content videos, filling out guided notes, and answering like a 10-question Google form that assesses their knowledge on the content that they just watched. So when they come to class the next day, they're going to use that content and do supplement activities that kind of talk about what they learned and kind of reinforce those concepts. So for the first day, the first lesson, they're going to start off with the do now, and then I create a playlist on Test Teach, which is also called Blend Space, and those are just a bunch of activities that students can work through in order to learn about electron configuration, which was the content video they would watch on the first day. The second day was lesson 2, and that is the content video on electron dot diagrams, and along with that they have guided notes and a 10-question Google form. When they come to class the next day, they're finishing up with their stop motion project. So the stop motion project, we're going to start it on the first day and then finish it off on the second day. And that stop motion project really assesses if they understand ionic bond transfer using electron configuration and electron dot diagram. The different objectives that these students are going to overcome is, one, they're going to learn how atoms become ions, and that's going to be important because they need that information in order to understand electron configuration, which is the next objective. They also need that information to learn electron dot diagrams and learn how to draw both of them. And then lastly, they're going to use all that information in order to show resulting ions and how these electrons can be transferred between a metal and a nonmetal. So this is my stop motion project, which is going to really assess the different learning evidence that the students are going to overcome. So on the right side, I have an example of the stop motion project from an example student. And then I have this procedural task analysis that I created for my previous assessment or assignment. And then it kind of compiles together to basically use all the information that they learned in the content videos and the lesson things. And it ultimately goes backwards, and it touches our goal that we wanted to master throughout this entire lesson. And I think this really did a good job with talking about how electron configuration and electron dot diagrams both model how ionic bonds are formed between metals and nonmetals. The last thing is the ISTE standard. The ISTE standard for this unit was to just explore and apply instructional design principles to create an innovative digital learning environment that engages and supports learning. I think this ISTE standard fits in with this unit plan because it talks about all the different components that the students will be creating and learning digitally on their Chromebooks at home. Thank you.